I have here a question on confidence intervals. To solve this question, you need to have some knowledge on normal distributions and making use of the standard normal probability table. Now let's get started. A large shipment of apples arrives at a grocery store. We would like to estimate the true mean weight of all apples in the shipment. We take a simple random sample of 22 apples. The sample mean weight is calculated to be 145.67 grams. Weights of apples in the shipment are known to follow a normal distribution with standard deviation 19.26 grams. The first question we are asked is, find the 89% confidence interval for the true mean weight of all apples in the shipment. So our goal then is to find the confidence interval of 89% for the true mean. Now let's look at this visually to figure out what exactly we're trying to do. The mean then would be in the center, and confidence intervals are always surrounding the center. So when you're asked to find any sort of confidence interval, it's going to be from here to here. It's going to be a range from the mean in the center of the distribution. So it's going to be an area, it's going to be the area around the mean like this. Now, in order to solve the first part of calculating a confidence interval, we need to use the following formula. We're going to need the standard deviation of the population divided by the square root of the sample size n multiply z. Z is the z-score, also the confidence level. Now we have all the data. We're given the standard deviation and the sample size, and we're given the z value, but it's in the wrong form. The z value, as I said, is the confidence level, which is 89%. But we need to convert that 89% into a z-score. Now, as I mentioned earlier, 89%, or rather a confidence interval of 89%, represents an area in the center around the mean of a normal distribution. And the normal method of finding the z-score for a probability or a percentage is using the standard normal probability table. But that only gives you a z-score that's representing everything towards the left side. So if we actually just used 89% into the table and got out a value, it would be wrong, because that's a proportion that's towards the entirety of the left side. And we're just looking for 89% of something that's towards the center. So in order to do this, what we need to find then is this tail area right here. We need to find the proportion or area that represents, then add that on to 89. Once we add that on to the 89%, we would be given a percentage that we can actually use on the table to find the proper z-score that would be right here. Finding this z-score right here is what we're trying to do. So then our first step is to find the area inside this tail. Now we just have to use some facts about normal distributions. We know that the total area inside a normal distribution is 1. Because we know that, we can find the areas that are not 89%, which are the areas of both tails, and we do that by doing 1 subtract decimal 89. That gives you decimal 11. 0.11 is going to represent both areas in the tail. But as you know, we are only interested in having one of the areas of the tail. So all we need to do then is divide this by 2. Doing that will give you a value of 0.055. This represents the proportion that is inside one of the tails. This tail right here, let's say. So then, the next step is just to add this value right here onto 89%. So we have 89, 0.89, add 0.055. This gives you a value of 0.945. This is going to be the proportion we're going to be using on the standard normal probability table in order to find the z-score that we have to use in this formula. So let's look at these. Let's take a look at the table. We need to find a proportion that's equal to 0.945 or just close to it. After looking around for a bit, this value right here seems to be the closest to the probability that we got. Now checking to the left, we see the value of 1.6. Checking to the top, we see a 0. Combining those two is 1.60. That is a z-score we're going to be using. Now let's go back to where we were. We now know the z-score. Let me just clear this up then. Okay, so our z-score is now effectively 1.60. Now it is just a matter of plugging in the data. We have a standard deviation stated as being 19.26. So we have 19.26 divided by the square root of our sample size given as 22 apples, so 22. Multiply the z-score we just found, 1.60. The z-score is the confidence level, 89%. Doing all of this calculation above will give you the margin of error. The answer to this is 6.5700. So this is our margin of error. Now to answer the question, all we need to do then is take the mean, the sample mean, which is given as 145.67, and we subtract first the margin of error we just got, 6.57, and that would give us the most left side of the confidence interval. It should give us the answer right here. And sure enough, if you did the calculation, you would get an answer of 139.1. That represents the minimum area in our confidence interval that where the true mean could lie. So in our 89% confidence interval, 139.1 would be the minimum value that we could be confident about where the true mean of the population could be. Now let's find the right side, the maximum value we could be confident about. The maximum value we could be 89% confident about. In order to find that, we just add the margin of error to the sample mean. Adding it instead would give you a value of 152.24, and that is indeed the answer towards the right. So that is how you answer the first question. This represents our maximum value of the 89% confidence interval. Anything exceeding this, and it's not going to be 89% confident, it's going to be 0% confidence. We have no idea what it is. Now let's move on to the next question. What is the 96% confidence interval for the mean weight of all apples in the shipment? So now it just wants to know the 96% confidence level. Well, we just have to take the same steps again. We need to know the tail value, right? So in order to do that, we do 1 subtract 0.96, giving us the value of both tails. That's going to be 0.04. We then divide that answer, 0.04, by 2 to get the proportion of only one of the tails. That's going to be 0.02. And then we add this value right here onto our 0.96. So 0.96 add 0.02. We do this because we need to find a proportion that we can actually use on the table. Because as if you can recall, a confidence interval is only going to be something towards the center of the mean. So we need to add the tail that's on the left to it so that we can actually use the table. So adding this together gives you 0.98. This is going to be the proportion or percentage we're going to be using on the table to find the z-score we need to use to make use of this formula right there to find the margin of error. So let's go back to our trusty table here and try to find something that's close to 0.98. This right here seems to be the closest actually. Checking towards the left, we have 2.0. Checking towards the top, we have 5.05. Combining those two together, we have 2.05, and that is going to be our z-score. We now know the z-score. The z-score is going to be 2.05. Now we just have to plug in the formula, or all the values into our formula, our trusty formula right there. So the standard deviation, if you look, is going to be 19.26 still, so 19.26 divided by the square root of our sample size of 22. Multiply the z-score we got, 2.05, and doing this will give you the margin of error for 96% confidence level. This gives you 8.4178. The next step then is to grab the sample mean and subtract this value by it and then add it by it. Those would give you the minimum and max values of the confidence interval. We know the sample mean is going to be 145.67 because it says it in the question right here. And so we subtracted by 8.4178, which is our margin of error we just calculated. That gives us a value of 137.25. And sure enough, that is the value we got right here. Now, just to find the maximum value, we just add it together, and that gives us, so instead of doing this, we add, let me just get rid of some of that stuff there. This now gives us 154.08, or rather 09 if you just round it off properly, and that is what we have right here. So that's how you would find the confidence interval of that question, of question B. Now let's move on to question C. What happens to the length of the confidence interval when we increase the confidence level? We just saw, if you compare these two, we had a confidence level of 89%. We had from 139 up to 152. We increase the confidence level to 96, now we have 137 up to 154. This one has a longer confidence interval. Therefore, we can say that whenever we increase the confidence level, whenever we want to be more confident about something, it increases the length of the confidence interval. Okay, that is the conclusion to this video. If you have any questions, feel free to ask them in the comment section below. I will do my best to answer them, and I hope you're having a nice day.